So for this first practice problem, we want to determine which of the following limits can be evaluated using L'Hopital's rule. So remember, we can use L'Hopital's when we get an indeterminate form like 0 over 0 or infinity over infinity. So we're going to use direct substitution for each one of these. On this first one, we'll have 2 minus 2e to the negative 0, which is still 0 power, over 4 times sine of 4 times 0, which is also 0. And remember that any base raised to the power of 0 is 1. So this is 2 minus 2. And the sine of 0 is 0. So this is 4 times 0, and we get 0 over 0. So this is a yes. We can use L'Hopital's rule for this problem. For the next one, we're looking at the limit as x approaches 0 from the positive side. So we're only looking for positive values of x. So again, if we use direct substitution, we'll have 9 over 0 plus 4 over 9 tangent of 0 plus pi over 2. 9 over 0, so as this approaches 0, is going to infinity. And infinity plus 4 is still infinity. Then we want to look at the tangent of pi over 2. And the tangent of pi over 2, if you think about the tangent function here, looks like this. We have an asymptote at x equal to pi over 2. And the tangent function is going to positive infinity. So we're going to have 9 times positive infinity, which is, again, infinity. So we get infinity over infinity, which was one of those indeterminate forms. For the next one, we're looking at the limit as x goes to positive infinity. And when we do that, we're really just evaluating the first terms of these polynomials. So we're really just looking at this. And when we put in infinity for x, we're going to get infinity over infinity. So again, we can use L'Hopital's rule for this one. Now for the next one, it's slightly different. We're not looking at whether or not the x goes to infinity, but as x goes to 0. So if we use direct substitution for this, we're going to get 3 times 0 cubed minus 9 times 0 plus 9. And then 9 times 0 cubed minus 4 times 0 squared minus 9. And we'll get 9 over negative 9, which is negative 1. So we don't need L'Hopital's rule for this problem. And then for the last one, we're looking at the limit as x approaches 1. So again, let's use direct substitution. And we have 2 cosine of pi times 1 over 2, which is pi over 2. And then 6 sine of pi times 1, or pi, plus 4. Well, at pi over 2, cosine is 0. So this is going to be 2 times 0. And at pi, sine equals 0. So this is going to be 6 times 0. But then we have this plus 4, which means we'll have 0 over 4, which